Good afternoon, ladies and gentlemen. I'm going to talk about the implementation challenges. Well, you know what? I thought I had another version of this. Oh well. But I'll focus on basically the technology-related implementation challenges with respect to the UID. And since several of you are from the industry, maybe I'll touch upon the opportunities that those challenges create. Well, the objectives, Bhaskar has gone through the UID system with respect to what it means, why we are doing it, and so on and so forth, so I will not repeat that. We'll quickly go into some of the details of enrollment and authentication and so on, and then let's look at the challenges. What are the huge challenges that are faced by us? So the UID enrollment requires very little information. It requires 4 fields: name, address, gender, and date of birth, the demographic fields. And then it requires 3 kinds of biometrics: 10 fingerprints, it requires the 2 irises, and then a photograph of your face. The idea is, if we get this information and you have already substantiated this information through a proof of identity and a proof of address, which could be one of 20 or 30 documents like ration card, PAN number, and so on and so forth, then you can be issued a UID. That is regarding, of course, if it is non-duplicate and you're unique. So one of the key things that the UID does is, you know, that diagram there shows the database of residents, and let's say you come up and say, I want a UID, and you give all this information. Your biometrics has to be shipped to the CIDR, and we have to check your biometrics against the entire database out there. If there's 1 billion people there, we have to compare your biometrics against 1 billion people, and there is no shortcut. We cannot say, well, it's in Hyderabad, so let's just dedupe here, and we'll dedupe elsewhere locally, and so on, because that leads to duplicate records. The point that the gentleman also made. So this is the largest computational problem that we're faced with. The issue, as the database grows, you have to do more and more and more work to give a single UID, right? And I'll show you some modeling that we have done with respect to enrollment rates and what this means with respect to compute power that we need. Of course, the number itself is a random number. There was a whole lot of excitement about, hey, should we put the district code and the state code and so on and so forth? Can we embed the year of birth and so on? Those things don't give us very much. They, in fact, give away information. Privacy is lost because now you have some maybe gender there, your date of birth. China has gone and embedded the year of birth. Sweden, in fact, puts a lot more information over there, but those are older systems. So we learned from them. And in fact, the social security number can also be predicted based on their death register. Using public data, I can predict your social security number if I know where you were born and approximately when you were born. So we have tried to remove all the deficiencies, and knowing which state, which district you were enrolled doesn't help when you move, right? In fact, it confuses the issue. So it's a completely random number. So if you look at this diagram, what you see is it's like a matrix. At the top is the UID backend itself, the CIDR, which is the central ID repository, which does 2 things. It does enrollment and it does authentication. The middle layer is partners. We have registrars. Bhaskar talked about registrars. These are state governments. These are maybe departments in state governments like PDS and so on, or LIC, SBI, and so on. These are partners who help us enroll in the case of enrollment, and authentication user agencies, which will actually use our database to authenticate during service delivery, as in the case of, let's say, PDS. Maybe people need their UID number and their fingerprint to get their food grains. On the lowest, you see the front end. Front end is where you have these stations, the enrollment centers with enrollment stations, and enrolling agencies are enrolling people on behalf of the registrar. And on the other side, it might be used in different service delivery locations for authentication, where be it NREGA, PDS, so on and so forth. Of course, it also shows an application of authentication, which is the financial inclusion. But I'll skip this since our Director General, Mr. Sharma, is going to talk about this tomorrow. So, of course, this is a snapshot of one of our POCs in Karnataka, in Mysore actually, where this lady is her iris is being captured as well as her fingerprints are being captured. So all these devices are basically plugged into a laptop or a desktop, and that forms the enrollment station, right? Now, there are several issues when it comes to enrollment, and the key part is the enrollment rates we are looking at and the deduplication that we need to do. If you look at this model, I mean, this might be, I'm sure there is an error of margin here, but still, we expect the enrollments to take off as more and more registrars come in and more people are enrolling across the country. And then it peaks at probably about 1 million enrollments per day from across the country. And then slowly after the database has filled up to a certain extent, maybe 500, 600 million, maybe more, it starts tapering off because you're going to tribal areas, you're going to Maoist areas, you're going to, not the mainstream. So now if the other curve, the curve that goes up is the accumulation, the cumulative enrollments. What is the size of the database? And it's actually shown in two different scales. The curve on the right is actually in crores. I mean, the red curve is on crores, the left, the blue one in thousands, right? So the key question is, let's say in about a year or two, we're getting 1 million enrollments a day, and we have to take every one of them and compare them against the database, which in this particular modeling shows about 400 million. So I have to take every record of the million and compare it against 400 million records to ensure that you're truly unique, right? So that we have done some sizing and so on, and obviously these are very, very large numbers. So one of the things that was imperative in our design of this system was that you don't keep on throwing hardware at this problem, right? Can we reuse existing systems? Can we build private clouds? Can we build elasticity around this system? Can virtualization be managed in such a way that our CIDR is able to see machines across the country virtualized in the exact same way as you would see in one data center? Can we administer security policies across all of these data centers in a uniform way? Do they all have to be UID data centers? Can we go to maybe the government of AP and say, hey, maybe in the night I'll use your data center if you're not using it, and I'll implement it in such a way that we just use it, we have a security perimeter, and out of there in the night. Can we do these kinds of things? Because we have to think out of the box. This is not about buying more and more and more hardware, because this is a very large problem. Okay, if you look at computational complexity, it's not an NP-complete problem mathematically, but it's a very huge scale problem. And to tell you about how large this scale problem is, the largest biometric database to date in the world is 120 million strong, which is in the possession of the FBI in the United States, right? Which is 10% of what we're talking about. So this is where no man's ever been. So when we talk to experts, it's not as though they have an idea as to how to solve this scale problem. So this is one of the biggest issues that we're faced with. Moving quickly to the next one, which is authentication. If you look at authentication, there, as the systems start becoming mature, more agencies will start using it. Maybe it's PDS today, maybe it's NREGA, then maybe even hotels could say, hey, just put your number and biometric, and if it checks out, then I don't need to ask you for your passport and this and that. It's much simpler. So authentication numbers will keep rising, and we think maybe in about a 4 or 5 year time frame, about 8 to 10% of the country, entire population of the country, will be authenticating if you go by the kind of, all the registrars we're talking to, which means about 100 million hits in an 8-hour period. Very large numbers. How do you deal with this? Okay. The first problem of enrollment, one, I talked about elasticity, about private clouds and so on. The other nice property, although it has a very nasty property of scale, the nice property is it's extremely parallelizable. The technical term is it's embarrassingly parallelizable, because we can take dedupe and actually run it across several different blades and cores, and you can put back the answer when they all come back together. So on the authentication side, although the scale is very large, you have 100 million transactions maybe every day, but the good news is it's completely read-only. There's no writes happening. We're just checking. Give me your UID number, give me your biometric. Does it match? Yes or no? Give me your UID number, give me your name. Does it match? Yes or no? That's it. That's going on. Right? We are not returning any data, nor are we writing any data into the database. We're just giving a yes or no answer, which is what you're using. So the good news about that is you can distribute many these systems in many data centers. I can keep one here in Hyderabad, one in Bihar, another in Punjab, and so on, and they're all having the latest data because we sync with the newest enrollments that have come in, and after that, you're on your own, you can do authentications, right? Of course, they need to be secure and all that good stuff. But it is we can handle these problems. Now, so what are we looking at? And how do we